Now let us continue with definite integrals LAQ. So the first question is, show that integral 0 to pi by 2 x by sin x plus cos x dx is equal to pi by 2 root 2 log root 2 plus 1. So let us take I is equal to integral 0 to pi by 2 x by sin x plus cos x dx. Now we have a property, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. This is a property of definite integrals which we are going to use here. So that is equal to integral 0 to pi by 2. Now wherever you have x, we take pi by 2 minus x. So this is pi by 2 minus x by sin pi by 2 minus x plus cos pi by 2 minus x dx. So that is integral 0 to pi by 2 minus x by, from trigonometry we know that sin 90 minus theta is cos theta. So sin pi by 2 minus x can be written as cos x. Same way cos pi by 2 minus x can be written as sin x dx. Now let us separate it. So this is pi by 2 integral 0 to pi by 2 1 by cos x plus sin x dx minus integral 0 to pi by 2 x by cos x plus sin x dx. Now you can see the second term is completely I, which I have taken in the first step. So this you can write it as is equal to pi by 2 integral 0 to pi by 2 1 by sin x plus cos x dx minus I. And left hand side also we have I. If I take this minus I this side, it will become 2I is equal to pi by 2 integral 0 to pi by 2 1 by sin x plus cos x dx. Now I told you whenever we have sin x and cos x in the denominator, we can take a substitution. What substitution is that? Put x is equal to, or else put tan x by 2 is equal to t. So if you differentiate this, you will get secant square x by 2 into 1 by 2 dx is equal to dt. So dx is equal to 2 dt by secant square x by 2. Now this you can write it as dx is equal to 2 dt by secant square theta. We can write 1 plus tan square theta. 1 plus tan square x by 2. Now this is 2 dt by 1 plus t square. This is dx. Now the same way, what is cos x formula in terms of tan x by 2? 1 minus tan square x by 2 by 1 plus tan square x by 2. So that is 1 minus t square by 1 plus t square. Now we have a formula for sin x also. 2 tan x by 2 by 1 plus tan square x by 2. So we got sin x value as 2t by 1 plus t square. This is sin x and this is cos x. Now after getting these values, when we do any substitution, I already told you limit changes. So lower limit will become, if x is equal to 0, then t will become 0. And how will the upper limit change? If x is equal to pi by 2, then t is equal to 1. Therefore, what is I? I is, see over here in this step, I will do one change. 2i is pi by 2, no? So I will be pi by 4. Okay, that I'm going to change in the next step. So what will be I? I is equal to pi by 4 integral 0 to 1 2 dt by 1 plus t square by 1 minus t square by 1 plus t square plus 2t by 1 plus t square. Now that is equal to pi by 4 integral 0 to 1 2 dt by 1 plus t square by 1 minus t square plus 2t by 1 plus t square. So 1 plus t square, 1 plus t square cancel. That is equal to 5 by 4 integral 0 to 1 2 dt by. Now if I take minus common from the denominator, we will get a minus outside and the denominator will change as t square minus 2t minus 1. So that is minus pi by 4 integral. Now if I take 2 outside, we will get dt by t square minus. Now here we are changing it as a plus b whole square or a minus b whole square. So this minus 2t I can write 2 into t into 1. Now in the place of b you have 1. So next term I want is plus 1. So we add and subtract 1. And already here you have a minus 1. That minus 1 I am writing as it is. Now 2 ones are 2 twos are minus pi by 2 integral dt by. Now see first three terms you can write it as t minus 1 whole square minus 2. That is minus pi by 2 integral dt by t minus 1 whole square minus root 2 whole square. Now we have a formula. What is the formula for 1 by x square minus a square? Now we have a formula. Integral 1 by x square minus a square dx is 1 by 2a log mod x minus a by x plus a plus c. This is the formula for integral 1 by x square minus a square. Now that is minus pi by 2 into, well, now wherever you have x you put t minus 1 and wherever you have a you put root 2. So this is 1 by 2 into root 2 log mod t minus 1 minus root 2 by t minus 1 plus root 2. After integrating, we will apply the limits 0 to 1, 0 to 1 and here also we take 0 to 1, 0 to 1. Now this is minus pi by 4 root 2. Now let us apply upper limit minus lower limit. So if you are taking one upper limit, then 1 minus 1 will become 0 and you will get log mod. Let me do this on the next page. So that is minus pi by 4 root 2 log mod t minus 1 minus root 2 by t minus 1 plus root 2 from 0 to 1. That is minus pi by 4 root 2 log mod 1 minus 1 minus root 2 by 1 minus 1 plus root 2. This is upper limit minus log mod 0 minus 1 minus root 2 by 0 minus 1 plus root 2. So that is minus pi by 4 root 2 into this cancel, this cancel. Then again root 2 also cancel. So you got log of minus 1 or it is modulus, no? So you will get log of plus 1. Log of plus 1 minus log mod minus 1 minus root 2 by minus 1 plus root 2. So here we get minus pi by 4 root 2 into log 1 is 0 into minus log. If I take minus common, we will get 1 plus root 2. Minus common 1 plus root 2 by root 2 minus 1. Now we are rationalizing the denominator. Root 2 plus 1 by root 2 plus 1. So that is minus pi by 4 root 2 into minus log minus of root 2 plus 1 whole square by root 2 minus 1 into root 2 plus 1 is 2 minus 1, that is 1. So that is equal to, if you take this, you will get minus. So you will get pi by 4 root 2 into minus will become plus. So you'll get pi by 2 4 root 2 into log 2 will come outside. You will get root 2 plus 1. So that is equal to 2 ones are 2 twos are pi by 2 root 2 into log root 2 plus 1. Now take the next question. Evaluate integral 0 to pi by 2 sine square x by cos x plus sin x dx. So let us take I is equal to the given question 0 to pi by 2 sine square x dx by cos x plus sin x. This is equation number 1. Now we know that integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. This is a property which we are going to use now. So that is integral 0 to pi by 2 sine square pi by 2 minus x dx by cos pi by 2 minus x plus sine pi by 2 minus x. Now we know that sine 90 minus x is cos x. So this is integral 0 to pi by 2 cos square x dx by sin x plus cos x dx. This is equation number 2. Now let us add 1 and 2. If you add 1 and 2, I plus I will become 2i, and numerators can be added because denominators are the same. So sin square x plus cos square x dx by sin x plus cos x. Now we know that numerator sin square x plus cos square x can be written as 1. So we write 2i is equal to integral 0 to pi by 2 1 dx by sin x plus cos x. Now I is equal to 1 by 2 integral 0 to pi by 2 dx by sin x plus cos x. So we have seen in the last problem, if we put tan x by 2 is equal to t, secant square x by 2 into 1 by 2 dx will become dt. Then dx will become 2 dt by secant square x by 2. Now secant square x by 2 can be written as 1 plus tan square x by 2. That is 2 dt by 1 plus t square. This is the value of dx. Then what is cos x? 1 minus t square by 1 plus t square. And what is sin x? dt by 1 minus x square, right? So 2t by 1 plus t square. This is sin x, cos x, sin x and dx values. Now we are substituting these values over here. integral 0 to pi by 2, 2 dt by 1 plus t square by 1 minus t square by 1 plus t square plus 2t by 1 plus t square. Now here 1 plus t square get cancelled from the denominator. So you get 2 I am taking out. So this will become dt by minus t square plus 2t plus 1. If we take minus common now, what do you get here? 2 to get cancelled. So you get integral 0 to pi by 2 dt by. Now if I take minus common, we will get t square minus 2t minus 1. Now minus integral 0 to pi by 2. Here we are adding and subtracting 1. So minus 2t plus 1 minus 1, and minus 1 is already there. So 0 to pi by 2 dt by t minus 1 whole square minus 2. That is minus integral 0 to pi by 2 dt by t minus 1 whole square minus root 2 whole square. So now we will take this minus inside. So we will get integral 0 to pi by 2 dt by root 2 whole square minus t minus 1 whole square. Now we have a formula for integral 1 by a square minus x square dx. That is 1 by 2a log mod a plus x by a minus x plus c. This is the formula. Now we apply the formula. 1 by 2 root 2 into log mod root 2 minus t minus 1 by root 2. Sorry, this is root 2 plus t minus 1, and here it is root 2 minus t minus 1 from 0 to 1, because the limits change from 0 to 1. Once we have done the substitution, the limits will change. So that is 1 by 2 root 2 into root 2 plus 1. Sorry, this is log root 2 plus 1 minus 1 by root 2 minus 1 minus 1 minus log root 2 plus 0 minus 1 by root 2 minus 0 minus 1. This is the application of limits. Now after you apply the limits, plus 1 minus 1 will get cancelled. So you will get 1 by 2 root 2 log 1 minus log root 2 minus 1 by root 2 plus 1. We can rationalize it, root 2 minus 1 by root 2 minus 1. So that is 1 by 2 root 2 into, this is 0 minus log root 2 minus 1 whole square by 2 minus 1 is 1. So that is, this 2 comes outside. You will get minus 2 by 2 root 2 log root 2 minus 1. So 2 to get cancelled, that is minus 1 by root 2 log root 2 minus 1. This minus can be written like this, log root 2 minus 1 whole power minus 1, because m log a is log a power m. Now this is again can be written as 1 by root 2 log 1 by root 2 minus 1. Again rationalizing, root 2 plus 1 by root 2 plus 1. So that is 1 by root 2 log root 2 plus 1 by 1. So that is 1 by root 2 log root 2 plus 1.